Good evening. Today we will see how to solve this engineering mechanics problem. This is basically taken from last year analysis question. So this is kind of a three-dimensional force which we have to resolve. The ideal way of resolving is this to project all these three forces and the reactions into separate planes and solving it separately. It will consume a lot of time. So that's why we are going to use vector mechanics to resolve this. Before going to the vector mechanics, we have to find out the length of the cables. So what we are going to do is that simply this is the xz plane projection of the problem. So you mark out all the dimensions. First, what we are trying to do is we are trying to find the OC. This OC length is nothing but you can find it using the simple 450 square, then 360 square. Then if you take the square root of that, you will get the length of OC. So after getting that, we can find the length of this tension cable. So it is AC nothing but OC square, OA square, then square root of that. So similarly, we can find out the OB length and OD length. So from that we can find out AB and AD. So after doing these things, so similar way I have found out other this one. What we can do now, we are moving to vector mechanics. So in the vector mechanics, sum of all forces is equal to 0 because it's in equilibrium condition. So force vector, if you want to detailedly read about vector mechanics and how to solve these three-dimensional forces, you can study Baron Johnson book. But as of now, I will make you to understand this force vector. F is the vector that vector value, and we can write it like a magnitude F multiplied by the unit vector. Unit vector is nothing but one unit of the vector in that force direction. So when you calculate this one AB, what we are going to do is A point, take that as a 0 0. So this is plus, this is minus, and plus y minus y plus z minus z. So like that, if you mark the point, you will get AB vector minus 320. So that means minus 320 I is nothing but unit vector in the x direction, j is unit vector in y direction, k is unit vector in z direction. So I point, when you make the AB vector, which is the AB vector, how we are marking this from A to B, the B point is minus 320 I. So because it is from the 0, it is on the left side, minus x, and 480 y. So from this A point it is 480, that is also in negative direction because above A it is a positive y, below A it is negative y. So we write as a minus 480. Then from this point this is it towards the towards us, that is a positive signature. So we put 360. So this is how you can write for AC and AD vector also. So now the point comes, the tension of the each cable is nothing but the magnitude of that and multiplied by the unit vector in that particular direction. This lambda AB unit vector is nothing but AB vector divided by AB, so that you will get the unit vector. Okay, so this TAB, and we know that lambda AB vector divided by AB, which we can take it from here. So 320 by 680, 480 divided by 680, 360 divided by 680. That is how this AB has come. Same way when you do, you will get AC and AD also. So we get three equations. So you get the three equations. So when you sum of all the forces, because of the equilibrium condition, it has to be 0. Same way, each plane, when you resolve the forces, it's going to be 0. That means you can take I separately, J separately, K separately, then it should be equal to 0. So every plane we can make it 0. The equation 1, when you make it in the x direction, which is I unit vector, then you get one equation. Then when you do it in the y direction, j, you will then again that for that also you get 0. Here you see the plus p, it is nothing but the force exerted at the point A. because of the reaction of the weight. So if you find it, then you will find it what is the weight of the plate. So in equation 3, same way we get K, when you add up the K, you will get this. So solving these equations, I hope everybody knows how to solve three equations. Simply by substituting we can simply solve. So 1 and 3, if you do it, and TAC equal 60 Newton is already given, so then you can get the TAB and TAD. You may find some slight difference between the book values and this values, the answers. This could be due to the number of digits I have taken. So when you slightly round off, there may be a small change. Otherwise, there is nothing wrong in this. So when you go to the apply this into equation 2, then you'll get the weight of the plate as a 866 Newton. This is how you have to resolve the problem. Thank you.